So project 4, which is not your ethics paper.
I tried, yeah.
All right, which I haven't completed yet. I don't know why there's a stopwatch here. Delete that. All right. LibreOffice Minisearch.doc. I'm going to present the project and then people leave. Interesting. Okay, Minisearch. The idea, since we were talking about Google, which is great, we're going to basically come up with a miniature search engine, just like Google does when you're searching documents or web pages. And the idea is that you'll be able to put in your and, or, not, and near operations inside of it and be able to actually complete the queries and come back. So the idea is that I'm going to hand you a bunch of text documents, which are just .txt. You do any pre-processing you want on those text documents. And then you might get a couple of queries. And your query must come back, do these text documents match or do they not match the query? So does the text document have this word in it and this word, or does it have one of these two words in it?
What do I have a feeling you're trying to give us something like a SQL database to work with?
No, not at all. That would be ridiculous. But we could do that.
No.
You could. Yeah, stuff in a SQL database. That'd be interesting.
A C++?
No, don't do that. Okay.
Sadness occurs.
So below is the required public interface for Minisearch. You may not change the public, but you can always add private. Class Minisearch has a constructor. This constructor has no documents. Obviously, that is completely useless. The Minisearch with a vector or string pointing to the files. And so you'd have to open the file, read in the file, and parse it however you believe is best. So files is a vector of file names, implemented by simply calling add document for each file. So Boolean, okay, so later, of course, after you construct it, you can add documents to your Minisearch. Opens and reads the file, returns true if and only if it was successful to read the file. This is the only method that should open a file, other ignored words, which we'll talk about later. The files will contain only lowercase words and no punctuation. There may be more than one word on a line. Use simple methods for reading a file rather than being concerned with speed. In other words, this parsing part is not supposed to be hard. It's just going to be a file with a bunch of words in it, no punctuations, obviously delineated by spaces and a new line. So use whatever you need to do. You can actually just what's it called, a file input stream, and just grab strings, and each string should be a word. And here, I'm not testing the time on add. Well, okay, I'm not going to test add document to your grade, but if I try and add a document and it takes an hour to add, a small text file, yes, you fail. But yeah, if it takes a minute per text document to set everything up, that's okay. I'm all right with that. We're doing a basic mini Google search, but with a bunch of text files. Later, we're going to have a query where I'll give you a string and then a vector result. Basically, the string is the query with what word I'm looking for and maybe another word. And then the vector string result should come back and tell me which documents matched that query. And Boolean print just says if I want to be verbose in what's being printed out. Blah, blah, blah. Yeah, prints the document in the result, otherwise it prints nothing. Query is constant because asking about the document shouldn't change anything. Private's whatever you want. All right. So queries. The simplest query is a single word. For example, I could ask hello, and then you must return a string or a vector of all the files that have the word hello in them.
This does not sound fun.
The method query should be set as a parameter or a parameter result. Yeah. Let's see. Throughout this specification, when the query is said to return or result in documents, what it really means is that the file names of those documents are placed to the result vector. Right. You're just querying based. Just give me back which files satisfy the query. Obviously, more complicated queries will be in all capitals. For example, your operators can be and, or, not, near, or near pound. So your code must support and, or, and not operations in order to get a good grade. If you don't have to do near, actually, but if you do near, you'll get some extra credit points. Those three operators require 2 words as operands and 1 before and 1 after the operator. Let's see, star, or as I call it, splat. Unary operator and near has 3 parameters. 1 word before, 1 word after, and then another word. All right, so and returns documents that have both the first and the second word in them. For example, hello and goodbye would result in documents that have both hello and goodbye in them. Hopefully everyone got that. Or return documents that have either the first or the second. You know, hello or goodbye. It could have one. It could have either hello, have goodbye, or it could have both. Just as long as it has one of them, go ahead and return it. So it's inclusive or. So not is really shorthand for and not. This is to make it a binary, operator, and therefore more consistent. Also, simply finding all the documents without a word would generally be a very large list. The query hello, not goodbye is short for hello and not goodbye. So in other words, your documents should have hello and not goodbye in them. You understand what I'm saying there? All right. Near is kind of more complex. It's similar to and in that both the first word and the second word must be in the document. However, in addition to being in the document, the 2 words must appear close to each other. How close is determined by the number given to near. For example, hello, near 3, goodbye means that hello and goodbye must appear in the document and that they must be in with 3 words of each other. So hello, near, goodbye would require hello and goodbye to be literally 1 word apart. You okay?
Yep.
Yeah, she sneezed.
Oh, bless you.
Thank you.
You may assume the numeric parameter to near is 1 digit and non-zero. So maybe you can do something by knowing that it goes 1 through 9. The operator splat is unary, meaning it has only one operator. So the query THI splat would find all documents that have something that begin with THI. So like thin, this, thinking, think, and thinks would all be found by THI. However, bathing would not count as THI is in it, but THI star means the word must begin with it. There will be at least 1 letter before the splat and no spaces between the letter and the splat, and no letters after. In other words, the splat's going to come at the end, always. All right, we're not going to try and mix it up. We're not doing complex regex here. Ooh, that'd be a cool project though.
No.
But we're not doing that here. No, but that's not what's happening.
Let's discourage this thinking.
Multiple operators and parameter and precedence. So as these operators get bigger, you can start combining them. For example, we got hello and goodbye and welcome. We return only things that contain all 3 words. The main issue is dealing with multiple operators is which one is precedence. Which operator should go first? Well, what we have. The way to handle is to go left to right. However, that can lead to some weird results. With near, for example, hello and goodbye near to welcome. It's a little confusing if the and is first.
So, are we looking for the words in the file name or
In the file itself. So you have to read in the entire file.
And we're going to have multiple files?
Oh yeah. I've set up the code to read in multiple files for you.
Oh, so you've given us some.
I'm going to give you something to start with. It's not completed yet, but I'm giving you something to start with. Now I should finish that up soon. But I'll commit it today so you can start playing with it. Well, the only part that's not working is the timing. I haven't done the timing, how long it's taking you to complete. Let's see. So what do we got? Star has to be first since it works on 1 operand. For binary, near has the highest precedence, then and, then not, and lastly or. So that is your order of operations. So splat, near, and, not, or. And if it contains more than 1 of the same thing, go left to right. I will not test your program with a query that has 2 near operators in a row. That's just mean.
Thank you.
Yeah, I don't even know what that would mean. Okay.
Not even.
Not even. Performance. Again, the performance of add document is not important. Just think about Google. Every time it visits a web page, it doesn't matter how long it takes to parse that web page. You only care about how long it takes to do a search on that web page. Because if it takes 10 minutes to parse it, then after 10 minutes you can do your queries in 0.05 seconds. You're fine. Who cares?
Who cares?
So you're really trying to optimize the query. So think about that. You're optimizing the query. In other words, don't rescan the documents ever. Scan them once, store them somehow in a data structure, and then query the data structure.
Can you store them in a string?
Sure, if you really want to.
That's a no.
All right, features and grades. For full credit, the query must be able to support something that does one word, so I highly suggest you do that first. 2 words with one operator, where the operator is and, or not, and then more than 2 words with the same operator repeated multiple times. So hello and goodbye and world. So this is not going to be that bad to get the standard grade. You should perform all these queries in a reasonable amount of time. I mean big O time, not the stopwatch time. Stopwatch time is what I'm talking about when I clock your code. So together with your documentation is worth 100 points. Naturally, you may get more by implementing the near operator, the splat operator, being able to combine multiple different ones, doing operator precedence, make use of list of words to ignore. Wow, you get lots of extra credit for this one. Ordering. Ooh, you can rank the results by some minimal measure, because that's what Google does at some point. Maybe if it has the word hello more than once, you could figure out how to rank it that way. Any type of additional operators I will gladly consider. I know Jonah has a ton, right, Jonah? Yeah, that's right. If you have any other ideas, please talk to me. Submitting. Oh, I'll fix this in a moment. But you're really just committing back to GitHub. In fact, let me do this right now. Part of your documentation of GitHub, there we go. The GitHub is explanation of your big O of your query. Bless you. This is 15 points, so you do need to actually think about it. Use the following terms. Big D is number of documents. Little u is the total number of unique words found in one document. W is the total number of words found in one document. Big U is the total number of unique words found in all. Big W is number of words found in all documents, and so forth and so on. R is the number of documents resulting from the query. Usually we talk about big O of N, just this time you'd have big O of D or U or whatever. So I want to know what's the big O on doing certain queries. So depending on your algorithm, data structures, you may or may not need all of the terms. You need other terms, just define them. You may use actually any STL you can find. So you can do the binary tree, you can use map, like a hash table. You can assume O1 performance with the hash table and search. Just make sure you look up what they are and say, I know that the map is O of 1, so that means that your query in this situation is O of something. Wow.
This hurts my head.
It does. I am not going to require the pseudocode. What's the big O of your query method as a whole? As on the exam, just say it's big O of D times U. Give me an explanation of how you figured out the big O. Describe your data structures, what operations, whether you have multiple operation or single query. If you support multiple operations, do you give the order precedence? Basically, make sure you tell me what parts of this you completed. And anything you're doing to try and improve performance, but we're not able to complete and why, aka I ran out of time.
This does not seem very fun.
All right.
Very complicated.
It can be very complicated. Let's go down to what code you have.
Sounds like it's a lot similar from the second project.
So let me go into the source, kind of. CPP. So if we jump down to the main, which I've written for you, or has been written for you, I should say. The first thing you're going to do is you need to, okay, let's not do that. Make, it's already made, no target specified, make. So if I were to run Minisearch, your parameters are files to search, yes, no for printing, and the search string to test. So when you run this, if I were to do an ls, you can see I have a docs directory. If I do an ls on docs, I have multiple document files. So you'd want to run Minisearch and then maybe docs/doc1.txt, and then you want printing and then the query maybe of help. When you do that, it reads in the file, read complete, pre-processing time, I add the document to your class, and then I do input phrase help, how many times it found it, and query of course took 0 matches because you haven't implemented anything yet. So one thing I've also done is you can do help and goodbye. Make sure your query is in quotes when you run this. Help and goodbye. If you don't put it in quotes, it'll consider them 3 separate queries, help and goodbye. So just make sure they're quotes. Got it?
Yep.
Is capitalization of letters going to count?
Yes, all words are lowercase. Capital letters mean you're doing an operation.
Okay, so when you're like reading the file, make sure everything in the file is lowercase. So convert
It is lowercase.
Okay, it already is. So we don't have to worry about that. Got it.
Okay, maybe it's not all lowercase. I is not.
Convert to lowercase.
Yeah, you can convert to lowercase. Just convert to lowercase. All right. Additionally, if you hand this program the directory docs, it's going to find all the docs, send it on, and pre-process all those documents. So, in other words, you can actually specify what document, a directory of documents you want it to scan.
And it already does that.
It does that for you right now.
So does it actually read in the documents already?
No.
Dang it.
We're going to go into your HPP file. Oh yeah, I never did this. So you have Minisearch.
Every single time.
Yeah. What happens is I create Minisearch, your Minisearch with just this default constructor. Then I call add document for every document I find, and then I'm going to call the query afterwards. Okay? That's what I'm doing. And that's it. Here are a bunch of notes that may or may not help you. Wow. Huh? You could also do a query helper function if you wish.
This is going to cause a lot of tears.
So, for example, like near to class, just document 1, like near 1 class, no docs. Let's go down to something a little more helpful. Data, doc1, doc2, doc3. Data and structures, just doc1 and doc2. Like or survey, doc1 and doc3. Data and structures and hey, doc1.
I wonder what that's for.
Any questions? All right, I'm going to go and due. Let me put a due date.
Anything else? Or?
This is due April 25th, 2017,
Okay.
which is the last day of class. There. And I'll commit this momentarily. Any other questions? Okay, great. Well, you have plenty of things to work on.